Assalamualaikum and hi. This is Group 5 MAT183 Calculus 1 Group Assignment.
Hi everyone. I am from group number 5. So today I'm going to present to you about the applied maximum and minimum problem.
So, this is our group members. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Adham bin Hasbullah. My matric ID is 2023 614 134 and program code is CDCS 110 and my course group is A4 CDCS 1102D.
I am the second group member. My name is Ahmad Akmal Hazim bin Sofyan. My matrix ID is 2023672084 CDCS 110. My group course is 1A4 CDCS 1102D.
Hi, my name is Muhammad Siddiq Hakimi bin Sopi. I am from class A4CDCS 1102D and my matric number is 2023865484.
Assalamualaikum. My name is Arif Daniel bin Johari. My metric ID is 2023809786 from program code CDCS 110, course group A4 CDCS 110 2D.
Introduction.
So, what is applied maximum and minimum problem? The process finding maximum or minimum values is called optimization. Many application problems in calculus involve function to find maximum or minimum values. Even in different field, in physics, for example, if, it's about optimizing trajectory. The thing they want to find is when a projectile is launched, and we need to find the maximum height it reached. So what? Why we should we know? Why should we learn applied maximum minimum problem? First is to understand the applied maximum and minimum problem. Second is to be able to solve the equation by using the suitable formula. The third one is to increase understanding about application of differentiation.
Problem statement.
So, we move to the problem statement. We go to the first question. A manufacturer wants to design an open box with a square base and total surface area of 100 cm square. The question is, we have two questions here. First question is, find the dimension of the box such that the volume maximum. And the second question is, determine the maximum volume. To solve this question, we need to know the information given and use them. First, we know that volume from this question is V equal to x squared times h, and the given surface area is 100 cm square. So, the total surface area equation for this box is x squared plus 4xh equal to 100. After that, we need to find the value of h. So we move the 4 and x to the opposite side. So the value of h equal to 100 minus x squared over 4x. After we got the equation for h, we can put the equation inside the volume equation so that v equal to x squared h will become x squared times the value of h. The value of h, we know that 100 minus x squared over 4x. After that, we can solve it and we got the answer of 25x minus 1 over 4x cubed. So that's the answer for volume. And now we can go to the first step. After we got the equation of v, we know that v equal to 25x minus 1 over 4x cubed. We can differentiate this equation and it will become, we differentiate 25x, it will become 25 minus differentiate of 1 over x, 1 over 4x cubed is 3 over 4x squared. In step 2, we need to let the derivative equal to 0. So we take the answer from the derivative we just done and equal it to 0. After that, we need to find the answer for x in this equation. So the answer of x after we settle down, it will become square root of 100 over 3 cm. And now we go to step 3, second derivative test. In this step, we need to second we need to differentiate the first equation second time. So the answer we will get negative 3 over 2x. And we know that the value of x is equal to square root of 100 over 3. So we can put the value of x into the equation and we can get the answer for second derivative test is negative 8.66. And 8.66 is below than 0. So the value of x equal to square roots of 100 over 3 cm is maximum value. And after that, we can put the value of x that is square root of 100 over 3 inside the equation of h and we can get the answer. So now we can do the task 2 from question 1. In this task, we need to determine the maximum volume of the box. So how can we determine the maximum volume? Is we use the equation Vmax. So in the first task, we know that V has two equations. The first equation is V equal to x squared times h. So we need to put the value of x and h into the equation. What is the value of x? The value of x is square root of 100 over 3 and the value of h is 2.89. And after that, we can get the answer is 289 over 3 cm cube. Or we can use the second equation of volume. The second equation of volume is Vmax equal to 25x minus 1 over 4x cube. So in this equation, we just need to put the value of x into the equation and we can get the answer is 96.23 cm cube.
So next up here we have question 2, where a rectangle door with a semicircle top as illustrated in the figure is to have a perimeter of 10 meters. So in this question, we are given three tasks such as express y in terms of x, show the area of the door is given by area equals to 40x minus 4x square minus pi x square over 8. And the third task is determine the maximum area of the door. To solve this question, we first need to identify all the given data, which in this case is perimeter equals to 10 meters. We know that to get perimeter, you need to count all the outer lines of a shape, which in this case is x plus y plus 2 pi r over 2 equals to 10. Afterwards, it will become x plus 2y plus pi in bracket x over 2 equals to 10. Afterwards, the pi outside of the bracket will be times inside, which will lead to x plus 2y plus pi x over 2 equals to 10. And then we'll be bringing the x and the pi x over 2 to the right side, which will leave the 2y all alone on the left side. And here, to simplify it, we have to times 2 by all of the other variables on the right side, which in this case, it will become from 10 to 20 over 2, and from x to 2x over 2, and leaves with pi x over 2. And since the denominator of all the data on the right side is the same, we can put it in all in one line, which will become 2y equals to 20 minus 2x minus pi x over 2. And the 2y will leave the y, while the 2 will be brought to the right, which will become 20 minus 2x minus pi x over 4. So here is solution for task number 2, which in this case, we want to find the same area as given in the task. First, we need to know what the area should be look like. So here, we know that to get the area, it should be something like xy plus pi r square over 2 is equal to a. So we need to substitute the y that we have gotten from task 1, which is 20 minus 2x minus pi x over 4, which will bring us to this, which is x in bracket 20 minus 2x minus pi x over 4 close bracket plus pi in bracket pi over 2 close bracket power of 2 over 2, and the x that is outside will be times by inside to open the bracket. So which will become 20x minus 2x square minus pi x square over 4 plus with pi x square over 4 over 2. Afterwards, it will become 20x minus 2x square minus pi x square over 4 plus pi x square over 8. So because the difference in denominator, the, we need to times by 2 to make sure that both of the denominators are the same, so we can put them together. So which will become 40x minus 4x square minus 2 pi x square over 8 plus pi x square over 8. Then we can simplify it by finishing it. So the answer, area, would be 40x minus 4x square minus pi x square over 8, which is proven that it's correct by the task itself.
So this is a solution for third question from question 2. This question is a equal to 5x minus 1 over 2x square minus 1 over 8 pi x square. For the first step is you have to find the derivative. dA over dx equal to 5 minus x minus 1 over 4 pi x. So for the second step is to let the derivative equal to 0. Let dA over dx equal to 0. 5 minus x minus 1 over 4 pi x equal to 0. 5 equal to x plus 1 over 4 pi x. 5 equal to x multiply with 1 plus 1 over 4 pi. And then you have to 5 over 1 plus 1 over 4 pi equal to x, and x equal to 2.8 meter. So for the last step is to find the second derivative test. dA square a over dx square equal to 0 minus 1 minus 1 over 4x equal to negative 1 minus 1 over 4x is less than 0. So x is equal to 2.8 meter is m maximum value. A maximum value is equal to 14 multiplied with 2.8 minus 4 multiplied with 2.8 square minus pi multiplied with 2.8 square over 8. And the answer will be 7 meters square. So, in conclusion, in this chapter, we explore how calculus is used to solve real-world problems by finding maximum and minimum values. We look at example in economics, physics, business, engineering, agriculture, medicine, and transportation. By using derivative, we can find critical points where function reach their high or lowest value. This technique helps us make a better decision, such as maximizing profit or minimizing cost. Understanding this, understanding this method is essential for solving practical problems efficiently and effectively. And that's all for us. Thank you.